Welcome back, everyone. This is Professor Hefe coming at you with the cross product, basic properties in the scalar triple product. This is in 11.4 of the Anton book. Let's just jump right into it. So we've got our basic properties. Remember, addition of vectors u plus v was the same as v plus u. That's the commutative property. Notice it doesn't hold here. Let's see. You need to turn this so that I'm comfortable. There we go. U cross V is not commutative. It's negative V cross U. So keep that in mind. Not commutative. Dot product was commutative. U dot V was the same as V dot U. The cross product is not, because we have that directional orientation of the outcome. It is distributive though. U cross V plus W is U cross each of those vectors individually. U cross V plus U cross W. Just like the dot product, when we multiply a scalar into it, we only can apply it to one of the vectors. So K times the cross product of U and V is either KU crossed with V or U crossed with KV. U times cross the zero vector is the same thing as 0 cross the U vector is 0. So that one is commutative, but that's because it's 0. U cross U is also 0. Remember, they're parallel vectors. Parallel vectors, what? Have an angle of 0 between them. You can work that out and check it out. And then we've got U dotted with U cross V is the same thing as V dotted with U cross V, which equals 0. And remember, if you want to remember why, U cross V, W was W. W was orthogonal to both U and V. So the dot product of two orthogonal vectors, U and W, V and W, is 0. Okay. If you work out U cross U, you're going to see no matter what you do, you'll have U1 V2 minus U1 V2. Each set of terms zeroes out. It just happens that way. Another thing is the cyclical order of how this stuff works. So if we look at IJK, I being 1 unit in the X hat direction, in the X direction, J hat being 1 unit in the Y direction, K hat being 1 unit in the Z direction. If I go counterclockwise, I can write a list of the cross products. A times J equals K, or A cross J equals K. If I don't start at A, I start at J, I can go J cross K equals I. If I start at K, K cross I equals J. So that sort of follows the way trig does. Trig, we go counterclockwise with radians and degrees. If we go clockwise like a clock, if I do I cross K, it's going to be J, but it's negative. K cross J is negative I, and J cross I is negative K. When we're going the clockwise order, it's the opposite sign. Remember, because it's that directional properties. Little things to remember. Then we have the scalar triple product. There's three ways of writing it. You take two vectors, you multiply or dot it with, you cross two vectors, dot it with the third vector. So my orientation, I've got U and V like this, W upwards. This process works. Whatever you have dotting it should follow the right-hand rule kind of idea. So if I align my fingers with V and W here, V, I can't even twist my arm like that. There we go. V and W, V's into the plane, W's up, U is pointed right. These do make, we're going to see that it does the volume of a parallel pipe head. This kind of looks a little bit cubish the way I wrote it. But there are two approaches to calculating this scalar triple product. Notice it's called the scalar triple product because B cross W is a vector. A vector dotted with a vector is a scalar. So the result is a scalar number. So two approaches, we could just do the cross product and then dot it with the other vector. Or you can do a super cross product. Rather than using IJK across the top, use U1, U2, U3, V1, V2, V3, W1, W2, W3. And just like IJK was cyclical, UVW is cyclical. As long as you got your vectors set up labeled right. Okay, let's take a look at an example using these. I've got two major uses of the scalar product, scalar triple product. I told you one, the volume of a parallel pipe head with U, V, and W. We want the absolute value of it because if you did the orientation in a funky manner, you're going to end up with a negative volume, but that doesn't make sense. So it's the absolute value of the volume or the signed volume. Notice I reoriented U, V, and W here, but it still follows the same rule. If U is my thumb and V is my pointer finger, like that, W is pointed into the page. U, V, W is pointed into the page. Okay. The other use for it is if the scalar triple product is 0, all three vectors are coplanar. You're going to have a problem in the homework where you do the volume of the parallel pipe head. I don't know that we really need to work one out here that much because we're going to do one with checking coplanarity. So let's check that. Let's check if three vectors are coplanar. We're going to do the U vector is 1, 2, 3. Vector V is 2, -1, 3. That doesn't look like pointy brackets. That's a fail, Mr. Jones. And W will be 5, 0, 9. So I didn't do the dot product method. I used straight to the super cross product rather than IJK. I put the third vector, the dotted product along the, or dotted vector across the top. And so going along the first row, 1 times its subvector, -1 times 9 is -9, -3 times 0 is -9 minus 0 is -9. 1 times it's -9. 2, remember I got to do minus here. I've got 2 times 9, 18. Subtract 3 times 5 is 15. 18 minus 15 is 3. And 3 times -2 is 6. Finally, we do our 3. This one's positive. The determinant of the submatrix, 2 times 0 minus -1 times 5. I've got minus is plus. 2 times 0 is 0. This is plus 5. So that ends up being the plus 15. -9, -6, and 15 do equal 0. So those three vectors are coplanar. I couldn't sketch those and see that if I tried. Okay, maybe if I put it in a computer program and oriented the angle such that I was looking down the plane, I could see that there was no up or anything going in or out of the plane. And I could see they're coplanar. So what do I mean by coplanar? If we've got some plane here, U, V, and W are all in the same plane. Okay. Some useful applications in physics are angular momentum and torque and the Lorentz force. Angular momentum is L when we do R cross P. Position cross momentum. Momentum is mass times velocity. When we're doing the Lorentz force, we have the electric charge times the electric field plus the velocity across the magnetic field. These are physics things. I think you do those in physics 3, not certain when, but that's when that comes up. Those are examples of the cross product, and that will be it for 11.4. Peace.